Hi guys, you are welcome back to my YouTube channel, Beloved Academy. This is the channel that you need. Thank you very much. Um, in today's video, we are going to be solving question on bulk density. That is, or the soil analysis test. Now we're going to be calculating bulk density, moisture content, volumetrically and gravimetrically, and host of others like that. But this is not in this video. I'm not going to solve all these questions in this video. I'm going to be simplifying it one by one. I'm going to solve only A, which is the bulk density in this video. Then in my next video, I'm going to solve the moisture content, and C in the next video, then D in the next video. That's what I'm going to do. And if you want to watch all the video, the full video from the beginning to the end, you can proceed to the channel and watch all the video. Thank you very much. Now let's proceed with the question. The question says a sample of moist soil was with wet mass. This is not is wet. There is T here. With wet mass 1.0 kilogram and volume of 0. This point not comma point. This point not comma 0.64 liters into bracket 6.4 times 10 raised power minus 4 meter cube was dried in an oven to form to have a dry mass of 0.8 kilogram. Now, I want us to underline our parameter. This is the dry mass, and this is what the wet mass. Calculate the following parameters from the given data. Number one is what? Bulk density. Don't forget that when you are talking about density, density is what? Mass over volume. And if you want to know the bulk density of this soil, which of the mass are you going to use? Is it the wet mass or the dry mass? It is the dry mass. You are correct. So the bulk density, and there is one thing I want you to know. If you are calculating the bulk density, you must make sure that this kilogram is converted to gram. When you're calculating for bulk density, make sure, or else if the question says specify that calculate the bulk density in kilogram per the unit that you are given, which is meter cube. But if you are not given any unit, if the question does not specify it, make sure that you convert this kilogram to gram and then your meter cube to centimeter cube. In that case, the bulk density will be in gram per centimeter cube. Okay, let's proceed with the answers. Just follow me carefully. Okay, now I have the parameters that I'm given here. Now, the first thing I want to do is to convert all these parameters to their necessary units. Now, they gave me that the mass of the wet soil, which I represented as MSWLs, mass of the wet soil is 1.0 kilogram. Now, the mass of the wet soil is 1.0 kilogram. If I want to convert kilogram to gram, don't forget that 1000 gram equals to 1 kilogram. So I'm having 1 kilogram here. So if I want to convert this 1 kilogram to a gram, so what I'm going to be doing is that mass of wet soil in gram, mass of wet soil. Let me use pen now. Mass of wet soil in gram, mass of wet soil in gram. What I'm going to be doing 1.0 multiplied by 1000 gram. So mass of wet soil in gram will be the mass of wet soil in gram will be 1000 gram. 1000 gram. So now the next thing I'm going to be doing is to calculate the mass of dry soil in gram. The mass of dry soil is 0.8 kilogram. So not 0.48, is 0.8 kilogram. The mass of dry soil is 0.8 kilogram. Don't forget that. So the next thing I'm going to do is now to calculate the mass of dry soil in gram. So I want to calculate that mass of dry soil in gram will be 0.8 multiplied by 1000 gram. So I'm going to be having 800 gram. So this is the mass of dry soil in gram. So the next thing is to convert this volume to centimeter cube. Don't forget that in your unit conversion, 100 centimeter equals to 1 meter. So I've already converted this to gram. I've converted this to gram. Then the next one is to convert the volume. I want to get the volume now in centimeter cube. So the volume is a meter cube here. I want to get it in centimeter cube. Don't forget that in your unit conversion, 100 centimeter will give me what? 1 meter. 100 centimeter equals to 1 meter. So if I want to get how many centimeter cube will give me 1 meter, don't forget it will be, if you square this like this, cube it like that, will give me 1 meter cube. Just cube it. So I've already cubed this. If I want to know how many centimeter cube will give me 1 meter cube, so I'm going to cube it. So therefore 1 million, if you multiply this, 100 raised to power 3 will be 1 million. 1 million 1 million centimeter cube. 1 million centimeter cube will give me 1 meter cube. So that's it. That's how to convert this. 1 million centimeter cube will give me 1 meter cube. Yeah, 1 million centimeter. So if 1 million centimeter cube give me 1 meter cube, how many centimeter cube will I got from 6.4 times 10 raised to the power minus 4 meter cube? Let me represent that as what? X. So x will be equals to what? 6.4 multiplied by 10 to the power of minus 4 meter cube. So now, the next thing to do, don't forget that if you have something like this will multiply this and this will multiply this. That's it. This will, 1 million will multiply 6.4 times 10 raised by this. And if you cross multiply like that, we are going to get the value of x will be what you calculate, that is 640 meter cube. 640 meter cube. The value of x will be equals to 640 and centimeter cube, rather, centimeter cube. So you have converted this 6.4 times 10 raised to power minus 4 meter cube to centimeter cube, and the conversion, this is equals to 640 meter cube in centimeter cube, rather. This in meter cube is equals to 640 centimeter cube. So now let's proceed with our calculation. Don't forget that bulk density is what? The bulk density is bulk density. Let me represent as BD. Bulk density is equals to mass over volume. Mass over volume. Mass over total volume. So now, which of the mass are you going to use? You are going to be using the dry mass, which is what? 0.800 gram. You know, you're going to be using the dry mass, which is 800 grams. So the mass is what? 800 in this case. 800 all over. What's the volume? 640. Don't forget your unit. 800 over 640 grams. 640 centimeter cube. So if you point your calculator, you're going to get bulk density BD is equals to 800 divided by 640. That is 1.25 gram per cm cube. So that is the value of the bulk density. This is the bulk density of the soil. As you know, the bulk density tells how sturdy the soil is. So this is the bulk density of the soil. Now, in my next video, you can proceed to watch how to calculate the moisture content volumetrically and gravimetrically. Thank you for watching this video. I really appreciate you. Please kindly hit the notification bell, click on the subscribe button, and if you want the channel to grow, I want you to tell me how you felt about the video. If you want the channel to grow, kindly subscribe to the channel and share this video to like-minded like you. Thank you very much for watching. Bye. And question B, which is the moisture content of the soil in the field on the basis of mass in percentage and on volume basis in percentage. However, I want you to take note. Probably if you are given a question whereby you are told to calculate the moisture content on gravimetrical moisture content, the gravimetrical moisture content is also known as the mass basis. However, when you are told to calculate the moisture content volumetrically, it is also known as the volume basis. So don't be confused. So without wasting our time, let's proceed to solving this question. Now, I want to calculate the moisture content on mass basis. I have my parameters here. This probably if you didn't know how I got all these this unit conversion, you can proceed back to watch the video. You can proceed back to watch the video on this channel. So now let's go on. Calculate the moisture content on mass basis. Don't forget, the moisture content on mass basis is also known as what? Gravimetrical moisture content. That is, we are calculating the moisture content gravimetrically. So now I can represent that as GMC. Let me represent as GMC. The gravimetric moisture content is equals to the mass of water itself. The mass of water over what? Over mass of the dry soil. Since we are calculating in percentage, you can then multiply by what? 100%. So the mass of water over mass of dry soil divided by 100%. So looking at this question now, you will realize that you are not given the mass of water, but we can get the mass of water from our parameters here. Don't forget that the only thing that makes the weight of the wet soil more heavier than the weight of the dry soil is the water content. Yeah. So if you want to get the mass of water now, you have to subtract the mass of your wet soil minus the mass of the dry soil. That will give me 1000 gram. The mass of water, let me put it, the mass of water is equals to mass of wet soil, MWS, mass of wet soil, minus the mass of the dry soil, mass of the dry soil. So I'm going to have 1000 gram, 1000 gram, 1000 gram minus 800 gram. So 1000 gram minus 800 gram will give me 200 gram, 200 gram. So this is the mass of the water. So this is the mass of the water. So let's proceed. I know the mass of my dry soil. The mass of my dry soil is 800 gram, which is this. So I don't need that. I can just proceed to put substitute all these parameters into the formula that I have here. So let's proceed with that. Yeah. Okay. So the gravimetric moisture content GMC on mass basis is equals to mass of water, which is 200. Don't forget it is here. Mass of 200 gram, 200 gram all over the mass of dry soil, 800 gram multiplied by 100. So if you divide this, you're going to have 0.25 multiplied by 100%. So that will give us 25%. So the mass of the moisture content of the soil in on the base of mass is 25%. So now let's proceed to calculate the moisture content of the soil on volumetrical basis. So that will give VMC. And the volumetric moisture content is the volume of water all over the total volume. Yeah, the volume of water all over the total volume. This is the mass, the moisture content of the soil on mass basis. Now, what I want to calculate now is the moisture content of the soil on volume basis. Now, the moisture content of volume basis is volume of water all over the total volume. In this case, the volume of water is also 200 gram. 200 gram all over. What is total volume? Total volume is 640. 640. 640. So 200 over 640. If you punch your calculator, you are going to get 0.3125. 3125. This is what you are going to get if you punch your calculator. So this is not the final answer because we are told to calculate this in percentage. So I'm going to be multiplying 0.315 multiplied by 100. 0.3125 rather multiplied by 100. 0.3125 multiplied by 100%. So 0.3125 multiplied by 100%, that will give me, so 0.3125 multiplied by 100%, that will give me 31.25. 31.25. So the volumetric moisture content is 31.25%. So that is how to get the volumetric and gravimetric moisture content per centimeter cube. Calculate the total pore space of the soil in percentage, and also calculate the void space within the soil in percentage. In this video, I'm going to be solving the void space. I'm going to be calculating the void space within the soil in percentage first. Now let's proceed with our calculation. The formula for the void space, I have my particle density here. The formula for the void space is the particle density itself, particle density all over the bulk density BD on minus 1. This is the formula for the void space. That is void space. Void, let me put it, void space. The formula for void space is particle density over bulk density minus 1. So the particle density is 2.65. Don't forget 2.65. 2.65 all over what is the bulk density? The bulk density is 1.25. So we're going to be having all these minus 1 equals to void space. Void space. So if you divide this, you are going to be having 2.2, 2.12. The void space, let me call it Vs, equals to, don't put Vs, so I just shortened it to put it on. So you're going to be having, divide this, you're going to be having 2.12 all over 1 minus 1. So that is 1.12. So the void space is 1.12, but this is not the final answer because I'm told to calculate in percentage. So the void space will be 1.12. The void space in percentage, is equals to 1.12. Just multiply this by 100%. So 100%. So the void space in percentage is 1.12 multiplied by 100%. That will give me 102. The void space now, the void space is equals to 1.12 multiplied by 100%. That will give me 112%. So the void space is 112%. The degree of saturation. So that's what I'm going to be calculating right now. Yeah, I have my degree of saturation as 59%. Don't be surprised. I'm going to explain it step by step. If you want to calculate the degree of saturation, this is the formula for the degree of saturation, which is the gravimetric moisture content multiplied by the particle density all over the void space. The gravimetric moisture content is 0.25 from our calculation. Then the particle density is 2.65. It was given in that question, and the void space that we just calculate is 1.12. So you want to calculate the degree of saturation. That is the degree to which the soil is able to permit water. So you are going to multiply. You are going to substitute all this into this equation. So after substituting all this, if you are going to be having this, which is 0.25, which is DMC, particle density all over 1.12. So if you multiply this by this, you are going to get this. Then divide this by this, you're going to have 0.5915. So if you approximate 0.1955 to 2 decimal places, you are going to be having 0.59. So and since the question says that you calculate the degree of saturation in percentage, I have to multiply these answers by 100%. So I have my 59%. Thank you very much for watching the video. I really appreciate you. Kindly click on the subscribe button to enhance the growth of the channel, and if you like the video, kindly let me know by liking the video,